Well, hello, I'm Carlos Solis, and today I'll be talking about the functioning of a binary tree code. Here is the example. These ones, each number is a node, and this is ordered as if this is a son of this one. This being the left son, and this being the right son, and each one has its sons. So I'll be passing to explain the code. Okay, so there is this class that is called the builder class, or as I call it, the core class. This creates a new node with the root as the value inserted, and then creates a left son and a right son, which are empty values. So this creates this slot with the value inserted, and then creates empty slots that in this case are the 5 and the 15. Okay, so the tree class, um, is needed to create the nodes in the right order. This creates an empty, this right here, creates an empty root to start the functioning of the binary tree. This sets the root option as a none option, like this is empty. Then there is this insert function that if the node is empty, creates a new node. So this function is called to create a new node. And if it is not, then calls the second insert option, that is this one, with the entered value and the root at that time. So this is the second insert option. Here, if the entered value is smaller than the root at that time, if the left node is empty, creates a new node. So then again, this function is called to create a left and right sons of that value. But if it's not empty, this same function is called, but now with the inserted value and the left node, as what we might call the root. So if that happens, it's like if this is already a number, then the function is called again to put that number as the root and um, create empty values. Right here, you create empty values and put in the left the value that didn't entered here, because there was already a value here. So there is this else that is basically to do that same logic to the right sons. Then so there is this else mean that means that the value entered is bigger than the root at that moment. If the right node is empty, this creates a new node, but if it's not, it's called the same function with the inserted value and that right node as the root. So again, the same logic. Here, if there is an empty slot, that value is put here. But if here it is already a value, this same function is called again to create in the right a value, an empty slot to put that value. Or well, if it is lower, it is put in the left. Having said that, now I'll be explaining some of the functions to print the tree in different orders. There is this order, this function that prints from the smaller value of the left to the bigger value of the right. First reads the left son, and then the parent node, and then the right son. in this order, then analyzes the next node of the right. So let's see it when running the code. All right. I think yeah, I'm printing two functions. I'll only print this one. That is the one I'm explaining. All right, here it is. So as you can see, it is printed the 3, then it goes with the 5, and it goes with the 7, 10, 13, 15, 18, and then the 20. It goes like that, like from the lowest to the highest, from the left to the right, passing through the nodes. Okay, I'll put this one in comment. Okay, then there is this function that prints at first the root, then continues with its left son, and if it is the case that that son has a son, also has a son, prints the one in the left and then the one in the right until passing to the sons of the root of the right and repeating the process. So let's see it. Let's see it while running. So I don't know if I printed correctly. Okay, well, it is first printed the 10, the root, then obviously we go with the left son. So there, that is printed, but it has already sons, so it has to print the left one first, as you can see here, the 3, and then the right one, 7. So all the so all the root left sons are printed already, so we'll be passing to the right sons. So it's printed the 15, that is the root's right son, and this one has already this one has also sons, so we'll be printing first the left one, and then we'll print the 20, that is the song of the 18, and then the 18, and that's how it's that's how it's completed, that function. And then there is the last order function. This function is, in simple terms, prints the sons first, printing the lowest node level son of the left, and then the right one of that same analyzed node. This until everything to the right of the node is analyzed. So let's see how it works. Okay, so first the lowest node level on the right, on the left, is printed first. So we have it here, the 3. Then of that same node, it's printed the right one. So there is printed the 7. Then the 5, and then we do not print the root, because first are the sons. So we will have to print the lowest of this level on the right sons. In this case is the 13, as you can see. Then we pass with the 18 of that same node, as I said, as I have already said. And then we pass with the sons of the 18. In this case, we don't have a left son, so we don't print like this is like we don't print any. We print like anything, and we pass with the right one. That is this one, the 20. And having that, we now can print the node, that is the 15, and we can print the root. So that's how it's completed that function. And then I'll explain a another function to run the code and search some of the values in the tree. That is like a search option. That this function is to find, as I said, a specific node if it exists. First is analyzed if the it is if it is the root. So if it is the root, right here, it returns, obviously returns the root. But if it's not, we'll have to search in the root sons. So um, we will have to determine if the value is lower or higher. If the value is lower of the than the root value, then we will have to search in the left sons of the root, and if it is the higher, obviously we'll search on the right sons, and this is going to be repeated until we find that that value. This is like perfect because this never fails, because it's like the same logic we used to put that we used to put that value where it is. So that's how it works, and we'll see it with the 15 right here. And as you can see, the 15 is printed because the code found it. Let's search for the 20, and then the 20 is it's found. Where I'll put a value that is in here, and let's see what happens, like a 2. Okay, and obviously there is no a value, so this code returns none. So that's how it works. This is very useful to know if a very big binary code, we don't know if it is a determined value, so we can use this code. So that's how it works, and I'll be passing to explain a example that I made. This is very interesting. This is very funny. I'll be using the first option to print the code, to see how it works, how this works, because I made it like very symmetrically to show each number from the left to the right. But first, let's see how this works, how the code works with the debugger. So I'll start debugging. Okay, and okay, the first value that we are going to insert is the 10 right here, as you can see. So let's see what's the value right here. Look, the 10. So if the root is equal to none, right, as you can see here, it's none, the root, then it is going to be created a new node with that value. So we go right here, we come right here, and it's created a left son and right son with a empty value, and then the root is created with that value that is the 10. Okay, then we return and we take this value right here. Okay, again, if the root is empty, it is not, so we pass with this. That is the else. Okay, this one is a call of the insert function. We'll go right here with the value that is in this case 6, and if it is um, lower, we're going to put it right over here on the left sons, and if it is not, we're going to put it on the right sons. In this case it's lower, so it's going to be in the left, as you can see right here. Okay, so this one is to know if it is the right node. It's empty right now. It is empty right now, so we're going right here and we're going to create a node. Okay, again we create a left song with the empty value for the right song, and that that um, that slot is filled with the value that we inserted, that is in this case the 6, so we already have the 6 in this position. Okay, the returns, and we'll go with the 14. Again, this is already filled with a value, we pass. Okay, this is higher in this case, so we go with the else, and this is empty, so we'll pass. We'll go to make another node. Again, the same thing. And for so far we have the 14 field right here, we have the 6, and we have the 10. Okay, here is where the things get a bit more complicated. We set the value as 20, and we go again. It is already a value. We go to insert. Okay, now there is a number. There is a number in one of these ones. In this case, there is a 14 because we are analyzing the right sons of the root, and there is already a 14. So we'll have to make slots to put that 20 somewhere. Okay, so we'll call this same function with the value, with this same value, and as a node, that node that is obstructing us. Okay, so let's see if, as you can see, the value is 14. It's 20, and this value key here is 14. So it is obviously higher, and then this is already this is like empty, so creates a new node in this position right over here. Creates the right and the left son, and sets that position with a value. Okay, and then the returns. We pass with another value, the 3, and having said that, the logic is already understood. So we'll find that here it's already a value, so we'll have to call again the function to create empty slots and determine if it's higher or lower. The 3 is going to be lower, so it's going to be put right here, right over here. So again, let's go. Okay, and we create it. Okay, the returns, and we'll go to this with the 7 again. This is lower than this, but there is already a value over here, so we're going to determine if it is lower or higher. In this case, it's going to be higher, so we're going to put it right over here. Okay. We create another node. right here, and we set okay here the value, the 7. Okay, the returns again, the 13. Okay, the same logic. Here is already a 14, so we create we determine if it is lower, higher, is lower, so we create a new node here. Okay, let's go, and here we go. We come here with the 13, as you can see, and okay, again with the 11. We'll have to determine if it is higher than this. It is. Here is going to be already a value, so we'll have to determine if it is higher or lower. Is higher, but here it's already a value again, so we're going to determine if that number again is higher or lower than this one, being in this case lower, so we're going to put it in the left songs of this node, putting it in here. Okay, look at this. Here it is, the 11, and it's set right there. With the 21, the 21 is going to be here because it's higher than this one. Here it's already a value, so it is higher, and then here it's a 20, so we have to know if it is higher or lower. Is higher, so we'll have to create a node in the right of this node, be in setting that value, that new node with the 21 value. Okay, look at this. The 21 that is set. Okay, now with the 1 again, it's lower than this one, it's lower than this one, so it's lower than this one. We create a new node with that value as the value of the node, as the node's value. Okay, and the value 1, that is this one. And finally the last value. Sorry for making it too long, but it was because I wanted to make it like more interesting at the time of printing it. So well, the 8 is called the function with the 8 value, and we'll determine if it's lower, higher, is lower. Then we determine if this is lower, higher, is higher, so there is already a value over here, and is higher, so we'll have to put it on the right sons of this node, that is the 7, and that's how it is going to be completed, this example of a binary tree. Look right over here, there is the 8. So the returns, and that's finished. Now having said that, let's see if this worked. We'll call the function to find each of the numbers. Okay, this is the first one, so we'll be reading it from the right, from the left to the right, like 1, 3, 6, 7, 8, 10, 11, 13, 14, 20, 21. Okay, so we find the 1, Alright, the 3, then we find the 6, then the 7 with the 8, and then we are going to find the 10, the root. Look at this, right over here, and the 11, 13, 14, 20, and then the 21, completing all the process of this code. Look at this. Compare these numbers. Here's the 1, then the 3, then the 6, then the 7, 8, 10, 11, 13, 14, 20, and 21. And I made it like I don't know, like a roller coaster or something. I really like it. When I analyzed the sprint option, like it came to my mind, and I was like, I'll do this just to make it like more fun. And that's how it is a functioning of a binary code. I hope you like it, and we'll see you soon, I guess.